Again, thanks again to John and all of you for coming today. What I'm going to talk about is what I see as the future of car manufacturing. Part of that car manufacturing is going to be castings. However, castings have to interface with what I think are the next generation materials, the material science. And actually, I just got something here from gaming that just solved me a problem. How do I fasten all these things together? So I'm pretty excited about the future, even though I'm an old guy. And I've really got an idea here of how many people are very interested in not just high volume products like the standard OEMs and whatnot, but also the low volume guys, because I believe that there's a way of making all these different volumes work for everybody. So, oh, I thought that was up. So anyhow, I don't want to go into a lot of detail. The one thing I am kind of proud of is I won the Henry Ford Award this year from the SAE. That was a surprise. The rest of the stuff, most of you know I have a YouTube channel, and most of you know that I've been alive for 76 years, and I spent a tremendous amount of that time working in the automotive world. So how do we stay current? Monroe is a teeny company with a huge voice. I know Elon Musk, I know Jim Farley, I know RJ, I know a lot of the people in the industry. They've done interviews with us, and those interviews are on Monroe Live. And that's kind of how I managed to know what I know. When people say, hey, is Elon going to do this? I can pick up a phone and talk to one of his people. So at the end of the day, I like to try and stay as far ahead as I possibly can. Now, this was kind of a surprise for me, but if you look over here, that's the symbol of Taurus, a constellation Taurus, and that says High Sandy. And that's the steering mechanism that's the card that's in the Cybertruck, which is steered by wire. And this is one of the things that I discussed with Elon and Lars quite a while ago, and they put my name on the circuit board. So I kind of got a good relationship with these folks. We've been around for 35 years. Mostly we work in new product development, benchmarking, costing. So I'm going to talk quite a bit about what we're seeing in the way of new product development today. I don't really care about the YouTubes and all the other stuff. Today I'm going to talk about things that we've worked on that actually got into the marketplace. This is what a lot of people know us for. And this is basically the area that we have showing off castings. So back there you've got the BMW i3. That's the cast frame that Elon saw when I basically threw rocks at the Model 3, which is the black thing. This is where he came up with two castings for the rear end of the Model Y, and then we've got the two major castings over right next to it, and then over here you've got what's left of the Cybertruck. Here's one of the castings here, and the other one's back there. So, and then the castings that we'd find on other types of products. So we really want to know how deep we can go, how much cost reduction can happen, and how can I make this the most efficient, effective product in the marketplace. And I will tell you, each one of these things that we're looking at, all of them, every one of them has issues. For instance, Tesla's castings are too thick. They're overdone. They could probably reduce the weight if they changed the flow characteristics a little bit more. Now, when I talked to them about that, they said they knew it, but they wanted to get into the market and make sure that they were over the top as far as strength is concerned. But I think mostly what they've got is redundancy. some of the castings that we look at are, they've missed the boat. They didn't take the opportunity to perhaps cast in little wells so that I can, it's easier for me on the factory floor now to install wire or install piping and whatnot. We're evolving. We're not really, there's nobody really that's got it all. Everybody should be trying a little bit harder to find out how they can get the most out of castings. And that's kind of like what I'm going to talk a little bit about. So the first thing I want to do, though, is let you know that everything at Monroe isn't always successful. Let me show you what happened at McDonnell Douglas. We worked with them on this cockpit. We came up with this. What did they implement? Nothing. So what I'd want to do is, I want to tell you that good ideas are going to come your way. You don't want to be like McDonnell Douglas. Anybody know who they used to be? They used to be an airplane company. They're gone because they implemented nothing, not just from us, but from everywhere on the planet. The idea for salvation and basically long life is implement. Don't kill ideas, execute them. Okay, that's what we have to be. So same kind of a product, the 787, totally different. With Monroe, we work with people, like I say, on these kinds of applications for the aircraft. We came up with a ton of great ideas. Ideas that could have been used with die castings, but we couldn't do it because the FAA, they just got in the way. The Federal Administration for Aircraft have a 1947 book, and that's why they won't move on it. I am going to try a little bit harder to make that happen because right now the U.S. is getting beat, not by Airbus, but by the Chinese. The Chinese now are in the aircraft industry, and hopefully now that there's a problem, maybe we can get them to move the 1947 book into a trash bin and talk about what is available in the marketplace right now. So these are kind of, and this is what happened. So with the Monroe system, they went from 3,500 hours down to 232 hours. That's kind of like what I think we should be seeing with automobiles. And what I'm going to try and put forward today is how do we get it to the point where there's only a few people on the assembly line and the rest of the work is being done somewhere else, castings being one of those areas. So we also worked on McLaren's vehicles, optimizing the cost and managing the cost. So on this one, I'm getting into where I want to be with castings. And so with this is an old video from BMW on the i3. And the reason that I'm showing this is because this was a clever idea. This was a great way of putting the body together. They came in, it was already glued, it was already ready to go, but then quickly they clamp it all up and the adhesive is already in place, and then they freeze the body in a matter of seconds. Seconds is a good way to look at how they got a good job done. Now, the BMW i3 unfortunately was as ugly as any vehicle could possibly be manufactured, but at the end of the day, they had a lot of great technology. We've actually looked at this thing because, quite frankly, all of the stuff that I need to make a better vehicle is all sitting there on the BMW i3. It was like a present that they gave to the whole industry. So if we look at the marriage of the product, there's really only 2 pins on the frame and 2 pins on the body. You lower it down, at first you put down, of course, the adhesive, and then you just lower it down, press it down, and that's it, it's done. That's amazing. And it's a bugger to get to pieces. It took us days with 2 people, actually 4 people because we had to run in 2 shifts, days to get those 2 things separated. That gave me an indication of why, or actually it begged the question, why are we doing all these bolts and all these other things that we do to make a pickup truck or anything on frame? And this frame here was made out of a bunch of extrusions welded together. But at the end of the day, this was the indicator, hey, if they can do that, why aren't we making an entire frame for a vehicle in one gigantic casting? Now, in that first slide I showed you, if you look at it, you'll see that there's a frame sitting there that is 100% cast. I got it about 20 years ago. It's been on my floor for 20 years. Every engineer I brought by didn't care. Elon Musk saw it in the background when I was criticizing the Model 3. He went to his people and said, I want that. And that's how castings basically got going in Tesla. This is a great idea, and this is how we're doing body assembly to a couple of the vehicles that we're working on right now. So BMW should have used the casting. So I'm just going to skip through this, but it's in the presentation. These are some of the best adhesives that we went to look at, okay? And it tells you the cure times. The other thing that I thought was neat was the onsets. These things are put on by robots later on, and this is what helps with assembly. So you've got a casting, and you've got a body, and you have these onsets, and this is what's going to help the guys on the factory floor. Design for assembly and design for manufacturability is what we do at the design phase. So these things here were extremely helpful, and they are made for a perfect build. And that's what we saw in the BMW i3, a perfect build. So why did they use carbon fiber? Well, at the end of the day, these are the reasons. The vehicle average weight was 350 kilos. That's like nothing. If we look at a body in white at 3,000 vehicles per year, it's $1,300. The average body in white investment, if I was going to do steel, is about $400 million. Paint's $190, and the paint shop investment was $300 million. This is minimum cost, but here's what it looked like when we got done with our assessments. It cut the investment by 65%, cut the time by 1.5 years. In other words, the time to develop the vehicle. It cut the weight by 50%, increased thickness, but the big thing was a perfect build. Everybody that makes cars has an oddball line where they go and fix things. Everybody. It's great if you can fix it on the line, but as a rule, there's some place where you have something that doesn't work because, who knows, a weldment bent or something normalized or stress relieved, and now it's not fitting anymore. But with the castings and with carbon fiber, everything goes clunk and it's always in the right place. So carbon fiber is something I'm very, very hopeful on, and that's what you're going to see when I talk about what are the three ways that we're going to see cars being built in the future. One is composite injection molding, one is high pressure die casting, and one of them is sheet molded compound. And everybody that I'm looking at right now, whether they're large volume or small volumes, I'm going in this direction. This was the BMW i5. It was canceled, obviously. This was the side ring for the BMW i5. Why BMW decided to go in a new direction is beyond me. They owned their own twill line. They could make their own carbon fiber. But I think that when the juggling went on, the political juggling, they decided they were going to go back to good old-fashioned, whatever, steel. But I don't see that. I see BMW taking a leap into the right direction and then retreating, and I don't know why. I don't know enough about BMW to know why they would continuously pull back, but I already know that thing passed crash tests and everything else. I don't don't understand it. So why do I like SMC versus the way BMW originally made their cars with resin transfer molding? Is because all those X's are steps that I can get rid of. How many people here know who Dr. Edward Demings is? Nobody. Wow. He's the father of quality. He's the guy that turned Japan into the powerhouse after World War II. Dr. Deming was my buddy, okay? And he kept saying the same things over and over again. If you've got variables, you're going to have problems. If you can eliminate 1, 2, 3, 4, 5, 6 variables in a process, you're going to get a higher quality product. People think, well, I got to have 5 bolts holding this thing together. Deming would say, why? Why can't you do it some other way? Why do you need 5 bolts when you should use 1? Because with 1 bolt, you're probably going to get higher quality. The more things you put in, the more likelihood you're going to get bad quality, or you're going to have problems later on. So if you look at a car with the number of stampings and whatnot that are in a vehicle, you're looking at a tremendous number of variation, and that variation gives you poor quality when you hit the factory floor. So with that in mind, have a look at one of the cars we are working on. This is the Aptera, and this is carbon fiber. And this will fit on top of a frame. Now, the frame that we wanted, they couldn't afford right now, but eventually this will be a casting, a complete casting. The reason that they couldn't do it now is because, unlike our friends in China, where governments are throwing money at products left, right, and center, these guys have to come up with investors, and investors have been in very short supply since COVID. This is what it will look like when it gets done, and that's what it's looking like inside. And you can see that all the connecting componentry here, the frame, is missing. And the reason for that is because there was nothing but arguments between myself and Chris and Steve, the 2 guys who own that company. At the end of the day, we will figure out how to put this together, and it will be a lower casting. And for this particular application, 1 casting should do the job, I believe, that on here, because it's a small vehicle, and but as soon as you get to a CD-sized vehicle, this I don't buy into it. So let's look at battery trays. I know everybody here is thinking, oh, battery trays should be aluminum. I don't quite understand that, because if I'm trying to cool a battery, and I happen to be in Phoenix, Arizona, as I'm trying to cool a battery and it's made out of aluminum, I'm also trying to cool down Phoenix. At 120 degrees Fahrenheit, that's really tough to do. And if I happen to be up north in Winnipeg, in Canada, if I'm trying to heat the battery and I've got an aluminum battery tray, I'm trying to heat Winnipeg as well. But what we came up with was a couple of different ideas. So there's a piece of 6000 series aluminum that I'm holding. It's a millimeter thick, and we took it up to 1100 C, and we put it up for 5 minutes, and I burned through. Now, what happens if I try that with plastic? Oh, guess what? There it is right there. Exactly the same test. Exactly the same test. And it bubbled it up a little bit. Exactly the same test. After 10 minutes, it still didn't burn through. Why am I using aluminum? Because that's what we always do. That's what we've always done. Remember that 1947 book that I talked about? The aircraft guys, oh no, you can't do that, can't do this, can't do that. See, look right here in a 1947 book. Somewhere there's a 1947 book in every engineer's back bookcase that tells them that they have to use something that isn't quite the right material for the application. And the reason they don't want to do it is fear. The biggest problem that we've got in North America and Europe is fear. We're afraid to do things. And the fear doesn't necessarily come from the engineers. It's going to come from upper management, finance, and lawyers. So somehow you're going to have to walk out of here a little more courageous and you're going to have to try and see how you can push the envelope. So this is what we came up with at Monroe. This is a representation of what we could do for a battery tray. And this battery tray is made out of Staymax, that same material that Cybercab has. This has the built-in cooling channels. I'm just going to glue straight to the top of them. After looking at every battery tray that Tesla cranks out, these things are one solid lump that you can't get anything out of. Tearing a 4680 battery cell out cost me $500 each. $500 each to take one cell out that'd be alive, something that we could actually test. That's ridiculous. But it's great from what do you call it, a recycling process. You just take the whole thing, throw it into a vat of liquid nitrogen, crunch it up, and now everything floats at different levels and you can get everything to pieces. They're looking at recycling the way it should be, and I'm looking at, well, wait a minute, don't I have to take this apart? What happens if I have to repair one cell? There's nothing you can repair, nothing, and they're all going in the same direction. We can't get, we have a Shark, BMW Shark, or BYD Shark sitting on our floor. We can't get a cell out. It's not possible. Not possible. They're all glued together. It's not possible. So this kind of a deal with everything glued down, I think is a better route to take. It's got a fire retardant. It's got electrical and thermal insulation, cooling paths. Cable connections are molded right in. High voltage wires are easily put in place. Battery locations, less weight, and it's less cost. And there is the first one that'll probably be going in, and this is going to VW, although it doesn't say there, but that's kind of like who's getting it. They're testing it right now. So here's what it looks like when you look at the old ID4 battery pack, and then you look at the one we came up with. And you can see here that the total cost was $1,662. And when we came up with the new battery pack, it dropped it to $875. That's kind of what we should be trying to push, is how do we make it less expensive, along with being safer, along with a whole bunch of extra features, and do it all, and the only way you can do it all is at the design phase. So you can see this video. Anybody that wants these slides is welcome to them. So we look at why I decided to go in the direction of castings. I actually worked on this plant layout when Mitsubishi was there. So I knew what they had in that building. I have all the process sheets. Myself and Mike Tracy, one of my guys, we basically checked the plant. We did the plant layouts for the assembly line, but we checked all the other layouts inside the factory. Those grayed out areas are areas that we don't need anymore because we moved from stamping and welding and whatever to going to die casting. And by doing that, we managed to get the plant size down quite a bit. We got 47% less floor space with Giga castings. That is a tremendous amount of money from a floor space standpoint. By the way, think about how much heating and cooling for the plant, on and on and on. This is the biggest deal, and nobody takes that into account. Nobody. Or just, it is what it is. That's crap. You have to be able to find out and cost everything that's associated with a new idea. Because if you don't have all the costs and they aren't right, we have a very good costing system. And if they're not right, or if somebody guesses wrong, then you've got a problem. In our case, we don't guess wrong. 8% less investment cost with a Giga casting. This is based on all brand new equipment. This is a greenfield site. Now, if somebody's got like a ton of suppliers and they've cheated, you know, they've outsourced and whatnot. In the United States right now, everybody's paying for that because they outsource to Mexico or China or wherever. And now Trump's going to take it all back in. They're going to have to go and buy new equipment. If they buy new equipment and they go in the same old stamped process, they are going to pay more for their investment. The system cost was 8.5% less with the Giga casting, and the system cost for the rear was 9.6% less cost. That's a big number when you start fooling around with high volume, but in low volume, it gets even more dramatic. With labor, 65% less with Giga casting. 65% labor, I don't know what it's like here in Europe, but in the US, if you have a union plant, 65% of the people disappear, you break out the champagne. And the reason for that is because the unions in the United States are really a problem, especially with the new guy who, I don't know, he wants to cause his own revolution. At the end of the day, getting rid of labor is a good idea, and the fastest way to do that is with castings. Quality with stampings, we get about 4 sigma out of that, but quality with machine castings, we're at 6 sigma. So I'm a big fan of high quality. Again, I trained under Dr. Deming. He's the father of quality. He said, get rid of operations. How many operations did I get rid of? Oh, I had 120 parts. Now I got 1 part. That's a pretty good, and it's stable. Welding, I didn't mention it, but I started as a tool maker. Then I went into engineering. Then I went into factories and whatnot. I got stuck with stamping lines and whatnot. I worked on dies, molds, and machine tools. So I've pretty much seen everything. So I'm not talking from a theoretical standpoint. I'm talking from, I had to make it work. I had to try and make sure that all these parts would weld together and on and on. So for me, I've got the scars to prove what I'm talking about here. So I look at this. This was in the front door of the IDRA building. This is one of the original presses, right? This is like number 2 or something.
Patent for die casting, yeah.
Yeah. So you look at this thing, and you got a guy basically locking in the mold, as it were, and then somehow this guy must be a brute. Somehow he's taking the dross and squirting it in. Wowzers! I've got a question for you. Could the engineer that developed this ever conceive of this? No. And the reason for that is because everybody is stuck in their little point of time. Everybody has to think about what they can do with the equipment that they've got. So hands off to the, or hats off, I should say, to the guy that came up with this. But this is revolutionary. Now what's going to happen? Well, just like the guy that had that little machine, we got this machine, what's next? We have to be thinking about what's next. And that's where things start to get complicated. So you've all seen this picture. This is the Cherry single-piece casting in China. Great idea. But I did a cost analysis based on 2 Giga castings with extruded aluminum rockers versus a single casting, and I wound up with a cost penalty. Not to mention, I may be incorrect on the floor space, but I believe that this sucks up more floor space than if I would have just 2 castings and whatever. But I'm not fully engrossed in this either. So I see 1 mold and 1 part, and I don't like that because this looks like waste to me. I want this kind of thing. I want to have multi-parts inside. Why can't I have this? Why can't I have a front and a... I was going to do this in CAD, but my January turned out to be, I have like 2 days in the office for January. I'm traveling a lot. But we have a front casting, a rear casting. We have all the parts that we need for suspension. And on top of that, when I spotted this, I got really excited because one of our customers is Honda. I should mention, we have 4 big customers, Ford, Honda, Hyundai, and and Aptera. So we have this kind of thing coming up here. This is what I want for a seat back. I don't want something that it takes two men and a boy to pick up and put together. This is one piece. I don't have to worry about anything not fitting. It'll all be great. And so I'm going to be bringing this back to Honda and saying, hey, you know what? Maybe you should do this. What's going to come back? What do you think is going to come back when I say, hey, this is magnesium? That one over there, I'll talk about that in a bit. But what do you think is going to happen when I tell the guys at Honda that this is made out of magnesium?
Material too expensive.
The material is too expensive. Did they do a cost analysis? Oh, no. Oh, no, we don't do that. Well, steel 16 cents a pound. This stuff, I don't know what magnesium is going for now, but somebody will have the answer. Yeah, that's it. Stop right there. Piece cost is not a driver. Piece cost or material cost is not a driver. You have to look at total accounted cost. And that's where everybody gets lazy. Nobody wants to have all the work that it takes to get total accounted cost. I want to know what the floor space is. I want to know what the quality is going to be. I want to know all the benefits of this die-cast component versus something that's welded together. And no one has ever given me, ever, and I've had the company now for 35 years, and no one has ever, from any company, given me a total accounted cost of any decision that they're trying to make. All they do is what's easy. Oh, this is more expensive from a material standpoint. Wow. And when I ask them, okay, good, what's your sigma value on the stamped and welded parts you got now? And the room goes quiet. Oh, how much floor space do you have? And the room goes quiet. How many labor hours do you have? And the room goes quiet. All they look at is piece cost or material cost. I think that you'd probably run your household slightly different, trying to make a decision on drapes faster than, or with more detail than what these guys will do on something that's going to go in every car that they've got. So at the end of the day, I think that somehow we should be making this. Now, remember that thing I showed you a bit ago? And I want you to figure out how to do this. So how do you do that? Well, you got to research with an expert. And one of the experts, I think, is sitting here in the office. So Marco, you got your assignment. Yeah. We want to see you come up with something like I just described. Elon Musk, all I said was a couple of words, and the next thing you know, he's got a car, and he did it in 18 months. So Marco's smarter than Elon, right? So anyways, so that's good news, but I'll tell you what, here's what I really want. I want Thixo in a huge form. If you give me that, I'll change my mind on everything. Everything. Oh, wait a minute. I'm sorry. I didn't know you guys were engaged. Anyhow, so anyways, this is what I really want. So I was told yesterday, Sandy, this failed and the company's bankrupt. And my thought immediately went to Henry Ford I. Failure is the perfect time to try again, armed with your new knowledge. If you fail, it's not the end. It's just another step. We have to figure out what the next steps are. That's what this whole process, the whole reason that you guys are here, is not to listen to somebody saying, oh, we got to do this, or this is the way we've always done it, or look what this, and getting pats on the back. That's all bullshit. What we really want to have is the thought starters to get us moving in the direction that I think the industry needs. Now for the last bit, anybody know what this is? Cyber taxi. I don't call it the Cyber taxi. It's called the Model 2 at Chrysler, or at Tesla. Okay, that's the Model 2. I've driven in it. I was there at We Robot. I got a chance to see it up close. They don't like me crawling under the car, so I didn't see everything. But I can tell you, when you go, bong, 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 and you listen for that ring, I know what that's made out of. And if I stick my hand underneath the rockers and feel around, I know what that's made out of. And when they showed me where the frunk was, and I saw a hole in a piece of plastic and felt around, I knew what that was, on and on and on. So here's my assessment. The current body is carbon fiber for sure. It's what I think is going to be a high volume sheet molded compound. I believe that the battery tray is going to be injection molded, similar to what we talked to before, because I was talking to Lars, the guy that's in charge of engineering, and in his conversation he mentioned Staymax, or a competitor to Staymax, but anyways, a competitor to Staymax that has fire retardant that's built into their plastic, on and on and on. And I believe that this could be a single casting because it makes sense. It's a small vehicle, it's a very small vehicle, and they want to try and make it so that it can be done at the lowest possible price. Now, when I put my hand under here, I could feel it was rough, but I couldn't tell for sure what I was feeling. I knew it was a piece of aluminum because it was colder than what I would expect, but at the end of the day, I believe that this is either a single casting or it's two castings with some sort of a small extension extrusion in between, and I believe that that's what is coming out. I will also tell you, the inside of this is definitely not up to a BMW. It's very crude inside, and that's the way they're going to keep it. They have things, the plastic that they put in is certainly not Tesla-like. It's heavy-duty, old-fashioned, and grainy. You can hose this thing out. So it's supposed to be a taxi. Taxis have drunk people come into them. It doesn't have a steering wheel. There's no accelerator. There's no brake. No nothing. All you do is tell it where you want to go, and it goes there. This is the kind of vehicle that every kid is going to want to get. Children today do not want to learn how to drive a car. It takes too long. It wastes their time. All they want to do is video games, and this thing has a thing for that built right into the system. We've made it with laws and trying to protect everybody. We made it now so that kids they're not interested in driving, period. So at the end of the day, this is the perfect car for Tesla to bring out right now. So anyway, thank you very much for your time, Carpe Diem, and have a good show. Yeah, thank you.